For question number 1, I've listed out the variables here because I really want to emphasize the fact that you have to understand what the information that's given in the question, where it goes. And the best way to do that is to list your variables. So as always, we're breaking up our problem into the vertical and horizontal components. So what do we know? We know that, so I mean, one of the things to keep in mind is when do you just like take a number like 240, 2.40 and stick it into your, I mean, that talks about a height. So does that mean it's the y? How about this 12 meters per second? Does that just go into the x? These are the kind of things that I really want you to start thinking critically about, because it'll help you answer these questions. So in this case, if we dial in on the initial velocity that Justin shoots the ball at, they say 12 meters per second directed at an angle of 35 degrees. So what that means is this green vector that they've shown you is the 12 meters. Now, some of that 12 meters is going towards projecting the basketball forward. So this part, and that's going to be our Vx. And some of that 12 meters per second is going to be going towards projecting the ball upwards initially, so that it leaves his hand and moves up. And we're going to call this V naught y. Remember, in the y direction, we've got acceleration. We've got gravity. So this is the 9.8 meters per second squared. And while we're here, let's pick a sign convention. Shall we make up positive and down negative? So then what we're saying is the V naught y, the initial velocity, is in the positive direction. When that ball eventually lands in the net, we can see that it is going to be traveling kind of like in this direction. So the Vx doesn't change because there's no horizontal acceleration. So that Vx is the same, but the Vy now, it's on its way down, Vy. And I'm calling that Vy, not V naught y, because it's the final. All right, so now that we've done that, let's see what we actually can put into our given information. So the delta y, this is basically the difference between where the ball started and where the ball ended. And you can see that it started at this point, 2.2 meters above the ground, right? So right about there. And it ends at the net, which is here, 3.05 meters. So the difference between those two numbers is 0.65. So our delta y, and it's up, right? It's moving and it ends up higher than where it started. So that means our delta y is positive 0.65 meters. We know that the V naught y, the initial y component of the velocity, is going to be 12 sine of 35. So we can calculate that out. And we also know that the acceleration is down 9.8, so negative 9.8 meters per second squared. The question is asking how far from the basket was Justin if he made a basket. Well, we want to know then how far horizontally. So this is what we're kind of, looking for here. And so we will put that in as a question mark here, right? So how do we solve this problem? Well, we can start by solving, we have 3 pieces of information. We can solve for time. This is my don't know, don't care. The time, obviously, for the horizontal and vertical, it's the same basketball, so they're the same. So we can substitute this in here. Now for the x velocity, we know it's going to be 12 cosine of 35, right? So let's figure that out. Let's start with the vertical. I'm saying my Vy is my don't know, don't care. So what I'm going to say is delta y equals V naught y delta t plus 1/2 a delta t squared. That's the equation we're starting with. So this becomes 0.65 equals, now what's 12 sine 35? Make sure you're in radians when you do this. So, sorry, let me rephrase that. Make sure you're in degrees. You don't want to be in radians, so you can just go to your mode and make sure you're in degrees. And it's 12 sine 35 is what we're looking for, and that's 6.88. So this is 6.88 t, I'm just going to call it t, and it's minus 4.9 t squared. So it looks like we have a quadratic equation here. So rearranging this to put it in the form of a quadratic, 4.9 t squared, I'm taking that to the other side, minus 6.88 t plus 0.65 equals 0. Now, hopefully you've had time to put this, delete. Hopefully you had time to put this into your calculator. I didn't, so I'm going to use the math.com quadratic formula calculator. My A is 4.9. My B is negative 6.88, and my C is 0.65. And when I plug all that in, I get 2 times. And I'm going to write them down here, and let's talk about what they mean. T1 is equal to 0.1018, 0.10187, and T2 equals 1.302 seconds. Does it make sense that we get 2 real times? Well, let's look at the problem. What we're basically saying is we want to know we want to know how long it took for the ball to get to a height of 0.65. If you carry this over, you'll see that there are actually 2 times. This would be the time it got there first, and this would be the second time, T2. So which do we want? We want T2. We want the longer time. So I'm going to select this one as my time that I'm interested in. Okay? Now, what we ultimately want is delta x. So let's say this becomes 1.302. So to find delta x, we just do Vx delta t. So we're just going to multiply these 2 things together. So 12 times cosine of 35, 12 times cosine of 35 is equal to 9.8298. 8298. And so this becomes 9.8298 times 1.302. So my delta x is equal to 12.79 or 12.8. 12.8 meters is and that's how far away Justin is from the net when he makes the shot. That's part A. Part B asks us a different question. It says, what angle to the horizontal, let me move this down. What angle to the horizontal did the ball enter the basket? So now we're interested in this orange vector here with the Vx and the Vy. Now what it's asking for is simply the angle, theta. So what we want to do here, we know Vx, we don't know Vy. Right? Because we treated it as our don't know, don't care. But this is a really straightforward triangle question. If we knew the sides, we can find the angle. So let's do this again. Let's say this is my vector. This is my vector, V, the final vector. And it's composed of a horizontal component, Vx, and a vertical component, Vy. Okay, we know Vx, we need to figure out Vy. So what I'm going to do here is list my given information again. Delta y, delta t, v0, v, and a. This is still negative 9.8 meters per second squared. My v0 is still the same. It's still 6.88 meters per second. The final velocity, now in this case, if you think about this, we know how far it went, and we know the distance, so we could still use that, we can still use 0.65 meters, but now it's my time that's the don't know, don't care. This is my don't know, don't care, and this is my I want to know. So I'm going to take that. So the equation without t is squared equals v naught v squared, vy squared equals v naught y squared plus 2a delta y. So then this is just a straightforward plug. So 6.88 squared plus 2 times negative 9.8 times 0.65. Plugging all that in and taking the square root of both sides, I get, give me a second here while I figure this out, 6.88 squared minus 2 times 9.8 times 0.65. Take the square root of that and we get 5.88. So the final y velocity is 5.88 meters, oh, it's 8817 meters per second. Okay, so going back to this triangle, I've now figured out this, which is 5.8817. I already know Vx, it's up here. It was 9.8298. This equals 9.8298. Now, how do I solve this? What I want is theta. What I want is theta. This is a triangle with a right angle. So what I have is the opposite and the adjacent. So I'm going to write this like this. The opposite. So what is opposite over adjacent? It's tan. So this is my equation. Tan theta equals opposite over adjacent, right? So tan theta equals, the opposite is when I take the square root of this, I really should have taken the negative because it's on its way down. So what I'm going to do is make that negative 5.8817 divided by 9.8298. Hi, Oak. Give me 1 second while I finish this problem. You can just wait 5 minutes and you can stay in here. So then we have tan theta. So dividing this out, I get 9.8. I'm just recording a video. I get tan theta equals negative 0.598. So this is something that you just have to, you just have to find what theta is. So you're going to use inverse tan. So I'm going to take inverse tan, second function tan of that number, and I get 30.89. So what I'm going to say here is theta equals 31 degrees. Okay, that's the answer. So I kind of went fast over the negative sign. When you take the square root of a number here, it's like basically what the line I skipped here was is, let me see. It is, I actually got Vy squared equals 34.59. And then I took the square root of both sides. So Vy technically equals plus or minus 5.88. And what I'm saying to do is pick the minus, because if you pick the minus, it's on its way down. If you look at this, Vy is pointing in the negative direction, right? So that means on its way down, it's going down, which is negative. That's why I moved a 9 negative here. And actually, if I put that negative properly, I would have ended up with negative 31. And another way to just say this is, if you said it in words, you would say theta equals 31 degrees below the horizontal. And that's the answer. So you could have left it as negative 31, or you could have described it as 31 below the horizontal. Both are correct. Okay? All right.